Hello everyone, this video is about maximum minimum point. Maximum means the peak, minimum means valley. So here we have a maximum point, a minimum point. So at the maximum point and minimum point, the gradient of the tangent is actually 0 because the tangent is a horizontal line. So here this is increasing, the gradient is something positive, the gradient is something negative, gradient is something positive, and at the maximum the gradient is exactly 0, at minimum the gradient is exactly 0. So maximum and minimum are two types of stationary points. We say that the nature of stationary points can be a maximum or a minimum. So maximum, minimum when the gradient is 0 and the gradient around it is like this. So if we have plus, minus, increasing, decreasing, we have a maximum. Decreasing, increasing, we have a minimum. So for example, find the stationary points and determine their nature and sketch the graph. This is the original function. To find the stationary points, we find the y prime and solve y prime equals 0. The y prime is, we differentiate 4 times 1/4 is 1, so just x to the power of 3 and so on. This is the y prime. We solve this, we can pull out the x. We have x squared plus x minus 6. We can factorize. We have x plus 3, x minus 2, which means the x can be 0 or minus 3 or 2. We have 3 stationary points. Now we use the sign diagram. We can check using any random point. So here, to determine plus minus, plug in a random number in the interval. So for the left interval, you can use something smaller than minus 3, for example minus 4. And if you plug in f prime of minus 4, you plug in minus 4 here or maybe here, you will get minus 4 plus 3, minus 4 minus 2. So basically it's negative times negative times negative, which is negative. So we have negative for the leftmost interval. And since it's just linear, so we have alternating actually, negative, positive, negative, positive. Or you can just use another number to check using, for example, minus 2 or minus 1. You check again, you get something positive. You use 1, you get something negative. You use anything bigger than 2, you'll get something positive. So negative means you go down, positive means you go up, negative down, positive up. So this should be the minimum point, maximum point, minimum point. So now for the sketch, we know we have a minimum, maximum, minimum. So this should be the rough sketch of the curve. And of course, to find the y value, we use the original. So to find the y value, we use the original. Y equals this. Plug in the x equals minus 3, you'll get minus 35/4. Plug in x equals 2, you'll get 5/3. Plug in 0, you'll get 7. So next, second derivative or higher derivative. If the original function is 3x to the power of 4, the first derivative is the dy dx or the y prime or the f prime, which is bring the power down. 4 times 3 is 12, the new power is 3. For the second derivative, we simply differentiate again. So bring the power down, 3 times 12 is 36, the new power is 2. The third derivative, we differentiate again. 2 times 36, 72, the new power is 1. Differentiate again, differentiate again. That's how you find the higher derivatives. Now for concave up, concave down. Concave up means opens upwards. Concave down opens downwards. So if we have this kind of curve, the brown part here is when the curve is concave down or opens downwards, and the green part is when the curve is concave up, opens upwards. We can only have a maximum when the curve is concave down. We can only have a minimum when the curve is concave up. So another way to find maximum, minimum, or the nature is to check using the double prime. So when the double prime is positive, the function is concave up. So positive means concave up. which makes sense. If the double prime is positive, the double prime means the gradient of f prime. So we know here the gradient is going down negative, the gradient is positive. The double prime is the change in this gradient. So if it's going from negative to positive, this means the double prime is increasing because the gradient is increasing from something negative to something positive. So double prime is positive means concave up, and concave up means we have a minimum. And conversely, concave down means when it's maximum. And actually we have something called the point of inflection when the concavity changes. So at this point here we have the point of inflection actually when the concavity changes, but we don't care about that. You just need to know when the double prime is negative, maximum. When the double prime is positive, minimum. That's it. So same example, actually it is exactly the same example as this one, exactly the same. We still find the y prime equals 0, the 0 minus 3, 2, but this time we don't use the sign diagram like this. We don't use the sign diagram like this, but we use the double prime to check. So the double prime is, we differentiate the y prime, we get 3x squared plus 2x minus 6. And now we plug in 0, minus 3, and 2, see what we get. When we plug in minus 3, we get 15, which is positive. And positive means concave up. Concave up means we have a minimum. When we plug in 0, we get negative 6, which is something negative basically. Negative double prime. Concave down. Concave down means we have a maximum. We plug in 2, we get positive again. Concave up again, so it's a minimum again. So we get exactly the same sketch, of course, minimum, maximum, minimum, and again to find the y value we use the original. So to find the x value of the stationary point, we use double prime equals 0, we solve, we get the x values of the stationary points. To find the y value of the stationary points, we plug in the x value to the original. So we use the original to find the y coordinates. We use the y prime to find the x value of the stationary points. To find the nature, we can use the number line or the sign diagram, or we can use the double prime. Double prime positive means minimum, double prime negative means maximum. Alright, that's it. I'll see you again.